Hello my dear shining stars, welcome back to physics class. Just as your knowledge climbs with time, displacement also changes with time. So let us represent it beautifully with the help of a displacement time graph. So here we begin with the displacement time graph. Children, whenever a body is in motion, its position changes with respect to time. So whenever a body is set into motion, as the position changes, then the parameters of the kinematic equations, that is the initial velocity, the final velocity, its position vector, that is displacement, acceleration, everything changes with respect to time. So let us try to represent the same with the help of a graph to make us clearly understand. So here we begin with. Before plotting up a graph, you need to remember that always the position is taken on y-axis, whereas time is always taken on x-axis. So here we go. First of all, let us consider the graph. So initially this is an x-axis and here is a y-axis. As I said that on the x-axis we always consider time, whereas on the y-axis we always consider position. Position is always taken on y-axis, whereas time is always taken on x-axis. Is that okay, children? Well, so if you consider any graph like some straight line, let us represent something like a straight line. Okay, children? Let this be a graph whose initial position starts at this position, whereas the final position ends at this place. So now, so here we could observe two different positions. This is the horizon time axis. Okay, the particle's position, initial position was at this place. Let us name it as some A, and it has ended up its journey after reaching position B. Okay, so here let us represent this position be some C and here be some D. Let us name it so. The initial position has started at a time T1 and the final position at T2. And this initial position on y-axis, let me represent it y1, and the final position, let me represent it y2. So if you observe the point A, its position was at y1 during the time t1, and the point B, it's the final position which is named as y2 as the final position in the time during the time t2. Okay, children? Well, now you know that according to the definition of velocity, the rate of change of displacement is called as your velocity. That means velocity is equals to change in position upon the time taken. Okay, or speed is equals to change in position upon time taken. Hence we can define velocity according to the definition of velocity. Velocity is given as change in position upon time interval, time taken. Okay, now time gap, time taken. So if you observe the same, velocity can be written as change in position. What was the initial position, children? Y1. And what was the final position? Y2. So what was the change in position? Change in position is nothing but final position minus initial position. Here was the final position. Position is always measured on y-axis. So final position y2 minus initial position is y1. Hence here we go. y2 minus y1 by time interval. This final position was at time t2, initial position was at time t1. Hence t2 minus t1. Let this be equation 1. Hence, velocity is equals to y2 minus y1 by t2 minus t1. Similarly, if you observe the graph carefully, then you see that here is a right angle triangle. ABC is a right angle triangle. From the triangle, right angle triangle ABC, if you observe this, let me name this as some theta. Then we have tan theta is equals to opposite by adjacent. For this theta, opposite is BC. So BC upon adjacent side is AC. So BC upon AC. This BC length is also equals to this AD length. So instead of BC, I can replace the same with AD. So AD upon, instead of AC, same thing, because for the same triangle, AC. Is that okay, children? So tan theta is also can be written as AD upon AC. But children, so tan theta is nothing but AD. This AD is nothing but this position, okay, from here to here. The length AD is nothing but the length from position from y1 to y2. It is nothing but y2 minus y1 upon AC is again this interval. That interval is again nothing but t2 minus t1. Let this be equation 2. It's very clear that we have observed that from equation 1 and 2, we have the value of V, we observed it as y2 minus y1 by t2 minus t1. Similarly, we observe the value of tan theta as also y2 minus y1 by t2 minus t1. Hence, we can conclude that from equation 1 and 2, from equation 1 and 2, it's very clear that V is equals to tan theta. V can also be written as tan theta. So that means tan theta is nothing but the slope of the graph. Slope of the graph, it is nothing but velocity. So velocity is nothing but the slope of a graph. Clear, children? So the slope of a position time graph always gives velocity. I repeat, the slope of position time graph always gives velocity. I can also indicate in the other way, the slope of displacement time graph also gives velocity. Velocity is nothing but the slope of displacement time graph. So note this point, children. Well, moving to the next concept. Next case, children. Let us observe one more graph. Again, let us take this x-axis. Let us once again consider x-axis, and here we go with y-axis, x-axis and y-axis. If you observe a graph something like this, curved shape, okay. Earlier the graph was a straight line. The graph was a straight and slanting up. Now the same graph, we observe it as a curved shape, okay. So in this case, if it is a slanting type, the straight line, then this is moving with uniform velocity. The body is moving with uniform velocity. I'll explain it in detail later condition. Well, so now I would like to explain clearly regarding the displacement time graph, only regarding the displacement time graph. So again, so for this, if I consider time on x-axis and position on y-axis, okay, this position can be either distance or it can be displacement, and here it is nothing but your time. Time is always taken on x-axis and the position is taken on y-axis. Position means it might be distance or displacement. But one thing you remember, children, distance means the total path length is called as a distance, whereas displacement means the shortest distance from the initial position to final position is called as displacement. So distance is always positive, whereas displacement can be positive, negative or zero. So as the distance is always positive, the curved shape, whatever we observe, it cannot be upward only until from here to here it is an upward motion. Again, it cannot come downward something like this. Like this it is not possible. Why? Because, so if it is coming down, if the graph is coming down, it indicates that the distance is decreasing. As time passes on, distance decreases. So distance is always positive. So distance will never decrease with time. Distance will never decrease with time because it indicates the total path length. The path length always increases. So the graph is only for the distance time graph, the graph is only the positive curve. Only upward motion will be there. So no downward motion of the curve exists. So this is the only case, only possible case. Is that okay, children? Well, but the same thing if you observe the displacement time graph. So what is the next case, children? We will talk about the displacement time graph. Here we go. This is time. The other one I would like to represent the displacement. And this displacement is always taken on y-axis. Displacement is always considered on y-axis. Time is always taken on x-axis. Okay. Suppose if the graph was something like this. The above figure represents that the graph is parallel to x-axis. The graph that is drawn is parallel to x-axis. So whenever the displacement time graph, this displacement time graph is parallel to x-axis, it indicates that the position is always fixed. What does it indicate? Suppose I'll try to explain you by giving few values like 0, 1, 2, 3, 4, so on. Here also 5 meters, 10 meters, 15 meters, so on and so forth. 15 meters and 20 meters. So if you observe the same, as the time passes, so for 1 second the position was 20 meters. For 2 seconds position is again at 20 meters. Third, 3 seconds also 20 meters. After 4 seconds also again it covers 20 meters. So from this it is very clear that even though the time is passing on, the position is fixed. That means the body is not moving with respect to time. That means its position is not changing with respect to time. That means the velocity of the particle is 0. As displacement is the fixed value, position is not changing with respect to time. So velocity of the particle is 0 because we know that the velocity equals to change in position by time. So initial position whereas a final position both remain same. So if this happens to be 20, here also 20. 20 minus 20, 0. 0 by anything. 0 by 4 you have 0. Hence velocity is 0. So it's very clear that whenever the displacement time graph is parallel to x-axis, then the body is said to be stationary. The body is said to be stationary. Is that clear, children? Stay for a stationary bodies, the velocity of the particle is 0. Clear? Well, moving to the next one. Whenever the displacement time graph is a straight line, so we will be representing a displacement time graph is a straight line, but it is not parallel to time axis. So let us try to understand the same. Okay. So here we go. This is your time axis and here is your displacement. So this is time and here it is displacement. Simply I will be writing it with yes, okay, or any other position. Now I would like to plot a graph which must be a straight line but not parallel to time. So it might be something like this. Straight line but not parallel to time axis. Okay, it is a straight line but not parallel to time axis. In this case, if you observe that, let me give the values, like this is 0, here is 5, time I'll take 1, 2, 3. 1, 2, 3, 4, 5, so on and so forth. Here 5, 10, 15, 20, 25, so on and so forth. If you observe this carefully, then the velocity of the graph is given by first case. This is the first case. Here is your second case. Here is your third case. Here would be some fourth case and something like this, fifth case. So every other aspect, it is clear that case 1, if you observe V1, what is the value of V1, children? So first case velocity is nothing but a change in displacement by time taken. Here first case, this point, if you observe, what is the change in position? Initially it was at 0, here it started, and here it is at 5. So 5 minus 0 upon time interval is 1 minus 0, that is 5 by 1 is nothing but 5 meter per second. Similarly, case 2, if you observe the velocity at this position, V2 is nothing but, at this case, the position is 10 and initially 0. So 10 minus 0, or else we will take only this particular region. Anything you can see. Okay, at this position, if you consider that, it is nothing but 10 minus 5. What is that, children? 10 minus 5 upon, this value is 2 minus 1. So this is again 5 by 2. Sorry, 5 by 1. 2 minus 1 is 1. So that is 5 meter per second. Again, for this particular region, if you consider, this is V3 equals to, this is position difference is 15 minus 10 upon 3 minus 2, that is equals to 5 by 1, again 5 meter per second. Similarly, V4 at this position, this is V1, V2, V3, V4. Any particular case, if you consider, for V4 we have 20 minus 15 is 5 upon 4 minus 3 is 1. 5 by 1 is again 5 meter per second. So from this we can observe that the particle covers equal displacements in equal intervals of time. Equal displacements in equal intervals of time. So whenever the particle covers equal displacements in equal intervals of time, we say that the body moving with uniform velocity. Hence, what velocity the body is moving? Every aspect, if you consider, the body has a velocity of 5 meter per second. Hence, we can conclude that the body moves with uniform velocity. But in the above case, the body was at stationary. So whenever the body was not changing its position with respect to time, its velocity is taken as 0. But whenever a body covers equal displacements in equal intervals of time, we say that the body moves with uniform velocity. One more thing I want to clear you, children. If you observe one more example, two different positions, something like this, V4 I have considered and V2 I have considered. Any two different positions. Okay. What is the displacement from here to here? Yes, it is displacements mean 20 minus 10. What is that, children? So this velocity, some V is nothing but, here the displacement is 20, here it is 10. That is 20 minus 10 upon time interval, if you consider between these two, this is 4 and here it is 2. 4 minus 2. 20 minus 10 is 10 and 4 minus 2 is 2. That is 5 meter per second. Here also. So any two different positions, if you consider, the velocity remains same. Okay. Hence the body, we can conclude that the body moves with uniform velocity. Is that okay, children? Well, so this indicates the displacement time graph moving with uniform velocity. Now, the last topic, let us consider something regarding the accelerated motion of a particle. That means variable velocity. So, velocity may change with respect to time. Here, the velocity is constant for every point, if you observe. But if you consider the variable velocity, the time would take something of this pattern. Okay. So, if you consider a variable velocity, the graph would be like a little curve-like structure. So whenever a graph is a curve-like structure, we can conclude that the body is moving with a variable velocity. Straight line, not parallel to time axis or x-axis means it is a moving with uniform velocity. But if it happens to be a curved shape means the body must be moving with variable velocity. So if lower curve is like this, means it is a moving with acceleration, and the same curve if it takes a format of something like this, then we can say that the body is moving with deceleration. Blue color indicates accelerated motion, whereas green color indicates the deceleration motion. So here we can go with one example of an accelerated motion, whatever. Remember, I told you that children, for any variable velocity, okay, the slope of the point at a given point indicates the velocity at that particular instant. So consider at this point A. To find the velocity of the particle at the position A, you need to consider the slope of that position. Say, let us indicate with some theta. So from the figure we have tan theta. Consider tan theta. We know that earlier I have told you that velocity slope of a displacement time graph gives velocity. So in the figure, what is the value of tan theta, children? Tan theta is nothing but opposite by adjacent. Opposite means this total length. What is this total length? 25 minus 15 upon time axis. Okay. What is the value of time? 4 minus 3. Is that okay? So 25 minus 15 is given by 10. 4 minus 3 is 1. Hence 10 meter per second. So if you would like to measure the velocity of a particle at a given point, then the slope of that velocity displacement time graph gives your velocity. So what is the velocity of the particle at this position? It is 10 meter per second. As and when we move away from this position, the velocity may gradually change. Okay. So within less time, as the particle may cover larger distances, so it is accelerated motion. Okay, clear children? So based on the above concept, and one thing I want to clear you children, here in the earlier example, you consider that the time can be, the displacement time graph can be parallel to x-axis. But remember that the displacement time graph can never be parallel to y-axis. That means the displacement time graph can never take a form of like this. Suppose if it is like this means, what does it indicate children? So here goes your time and here goes your displacement. So that means at a fixed time, something like 0, 1, 2, 3, 4, so on, and here is 5, 10, 20, 30, whatever it is. At the time interval t, 2 seconds, during 2 seconds, it can't take a different position, like at 2 seconds, once it is at 5 meters, the other time it is at 10 meters, 20 meters, so it is a contradictory. So this type of graph never exists. That means displacement time graph is never parallel to y-axis, displacement axis, but it can be parallel to time axis. What does it indicate? As the time passes, the particle is fixed to some position. But particle's position is changing, but the time is fixed is a contradictory statement. Hence, the displacement time graph can never be parallel to displacement axis. So, just ignore this type children. Okay. So, based on that, let us try to solve few numericals.